Okay guys, continuing with example 12.4, single stage double acting air compressor is required to deliver 14 meter cube of air per minute measured at 1.013 bar and 15 degrees C. So this P1 and T1, this is also known as the free delivery condition or the ambient condition. The delivery pressure is 7 bar. This is our P2 and the speed is 300 rev per minute or RPM. This is the speed of the compressor. And then we take the clearance volume as 5% of the swept volume with a compression and expansion index of N equal to 1.3. So this is assuming the compression and also the expansion as a polytropic process. And we need to calculate the swept volume of the cylinder, the delivery temperature and the indicator power. So I have put on the data given to this double acting compressor. So due to this is a double acting compressor, meaning that we have two sides of intake and two sides of delivery. So this 14 meter cube per minute is basically based on the whole double acting compressor. So in order for us to look at the swept volume, we need to look only at one side. So if we observe only for one side, we are going to have the volume or the free air delivery of 14 will become 7 meter cube per minute, which is 14 divided by 2. And based on that, in order to get the swept volume, we need to look per cycle. So this is our PV diagram for per cycle. Okay, with all the given parameters properties of air inside the compressor, then we can look here. We have two type of IGES, ideal gas equation of state, whereby we have the state 1. This is our state 1. And if we look at the IGES, this is a P1 VA minus VD equal to MRT1. And then for the next one, we have the state 2 delivery, which is a P2 VB minus VC is equal to MRT2. So in order to solve for this VS, it's easy, or we can try to relate the VA and VD in this equation in order to get the VS. Why? Because in this case, if we look carefully, we can see that the parameter given in this question, which is a P1 VA minus VD equal to MRT, the VA minus VD is already given in the question. Okay, the VA minus VD is already given in the question. Or we can try to get what is VA minus VD in this case per cycle. So in order to get the value of VA minus VD per cycle, if we look here, this is our condition of VA minus VD. This is the amount of air being inducted into the compressor. So for double acting, the amount involved right here is 14 meter cube per minute. That's why we have to divide into 2, because we are looking only for per cycle, or we are looking only for one side or single side. So we can have our value of this VA minus VD right here. So basically, based on the IGS of state 1, we could have the VA minus VD, which is equal to, let me write that in terms of the equation. So the VA minus VD is equal to the V dot A minus V dot D divided by N. Okay, so in this case, this is a 7 divided by our RPM of the compressor, which is 300 RPM. So this 7 meter cube per minute, and the RPM is 1 over minute, then we can find that the minute will be cancelled off, and it will be left as the unit of meter cube per cycle. Okay, so meaning that we are going to have this VA minus VD in term of value. Okay, in term of value, and let's say this is our equation 1. This is our equation 1, and then we try to relate the VA minus VD. Okay, try to relate the VA minus VD. Try to put the VA minus VD in the function of VS. So this is our value of or our state of A. This is D, and we can find that what is VA? The VA is VC plus VS, and we can find in the question that the VC is given in term of VS. So we could get what is VA in term of VS. So let us put that equation first. So what is VA? The VA is equal to the VS plus VC. And we know that the VC is put in term of VS. So this is VS plus VC is 0.05 VS, and this will lead us to the VA in function of VS as 1.05 VS. Then next, what we do, we try to look at the process of C to D. Okay, so we look at the process of C to D. This is the process C to D. Then we could write that we know that the expansion process is basically following the polytropic expansion process. So now we put here for the process from C to D, we can put here, this is P C VC power of N is equal to P D VD power of N. Okay, and we know that what is PC? PC is the top part, which is the P2. So this is becoming P2, and we know that we could put the VC in terms of VS later on. Let us substitute the PC and PD first. So this is P2, VC power of N is equal to, and PD is equal to our P1 VD power of N. And from this equation, it will lead us the VD, where we can find out the VD in terms of VS later on, where we can put here the VC in terms of VS. So what is VD? Basically, VD is equal to VC P2 over P1, P2 over P1. So we put the exponential or the N value right here. So what we have right here is 1 over N. So let us look here. Am I doing it correctly? So this is VC, this is VD. So it's 1 over N. So basically, from this equation, we are going to put the VC into VS. So let us continue putting them, all the figures. So this is VD equal to 0.05 VS. And then we know that the P2 is 7 bar. And the P1 is 1.013 bar. And this is 1 over N is given as 1.3. So what we could have right here, this is in term of Vs. So this is our Vd in term of Vs. And finally, what we could have and what we could write is the Va minus Vd itself. Okay, the Va minus Vd itself. So please bear in mind, this is in term of figures, numbers. Okay, so after that, what we do, we are going to write what is our final equation for Va minus Vd. So the final equation of Va minus Vd will be Va minus Vd is equal to 1.05 Vs minus our Vd. Here is our Vd. This is the value of our Vd. Sorry. Vd, which is this value. The value, say the value as A. Let's say this is A. This is A in terms of Vs. So we are going to have a new Va or a new function of Va minus Vd. So you are going to have there is the value. So this is in terms of Vs. Let's say this is our B value. Okay, that is our B value. So this is B. So let's say this is what we have for the next equation, which is second equation. Okay, so now what we do, we equate equation 1 to equation 2 and equation 2, and this will lead us to the value of Vs. Okay, so guys, please have a try of this example. And then the next one, the next question is to get our delivery temperature. Okay, delivery temperature. And for delivery temperature, we could use the relationship between T and P. Okay, T and P. So what is our relationship between T and P? So we can write here the T2 is equal to T1 P2 over P1 power of n minus 1 over n. And please remember, in this equation, the T1 should be put in terms of Kelvin. Okay, in terms of Kelvin. So you must put this in Kelvin. Then given the P2 and also the P1 and also given, then using this for this equation, we could solve for T2. So in Kelvin. Okay, and it depends on the question. If they ask for in Celsius, then you change in terms of degree C. Right? And then lastly is to get what is the IP. So what is IP? IP is in the indicated power, the power needed in order to get the compressed air stated by the question. So this is basically the formula of n minus 1 m dot r T2 minus T1. Okay, and from here we need to resolve for this m dot first, because if we observe carefully, we have the n value, we have the r value for air 0.287, we have the T2 and we have the T1. So we need to get what is our value of m dot. Using the IGES for state 1, we will get the m dot equal to PV, which is our Va minus Vd, and because this is dot, then we need to put this as dot also. Okay, and divided by RT1. Okay, now be careful. You want to use the VA dot minus VD dot. In this case, you must use the total of the inducted air to the compressor. So in this case, the value, right? The value of VA minus VD, you need to use as 14 meter cube per minute. Okay, because we are going to have this IP is for the double acting compressor. If you use right here as 7, meaning that you are only calculating the one side of IP. But in this case, the question asks for the IP for the compressor. So you need to have the total M dot, which is comprises of the double acting or the two sides of the compressor. Okay guys, so you should get the answer for the IP from the textbook. You can have this IP as 57.6. So give a try and make sure that you have all the correct answer as in the textbook. So this answer should be equal to 57.6 kilowatt. Okay, and then one more thing, make sure that you also get the conversion from meter cube to meters cube per second, so that we can get this M dot as in kilogram per second. So when we have the M dot in kilogram per second, then only we could get the IP in terms of kilowatt. So guys, please give a try. Okay.